Hello and welcome to Module 2 for the Karumba tutorials for parametric structures. Once again, I'm Muhammad Ismail, and for this part 1 of Module 2, I'm going to talk about the assembly parameters, and more specifically cross-sections. So when you go to Rhino, what we had last time was this definition, which pulled from geometry made in Rhino and then analyzed it after you applied loads to certain points and chose certain other points to be the supports, went through the assemble and analyzation, and then viewed the results in the output. For Module 1, we basically focused on this starting part, starting half of the definition. Now we're going to look at the second half, the assembly, and then the results and output. So for this part specifically, I'm going to look at cross-sections. Now if you remember, in the assemble command, we didn't actually define a cross-section of material because Karumba can work off of a default for those unless you explicitly say that you want something else. So I'm going to show you how to pull cross-sections from a database of standardized cross-sections. So first, I'm going to open the read cross-section table. This is a really useful command. It pulls from tables of properties of cross-sections. If you remember from your structures, every cross-section has a different moment of inertia, different property, different weight, things like that. And if you double-click and put a double slash to open the panel up, and then draw from the cross-section, what you get here is a table of names, which in and of itself doesn't actually tell you anything except for the very basic stuff. If you understand how to read columns, or how to read members, steel members specifically, W8 by 18, things like that, this is what it tells you. If you want to know the structural properties of each of these cross-sections, you can actually go to the Karumba folder in App Data Roaming Grasshopper Libraries Karumba, and you'll have a couple of these strange Excel sheets, and I opened a couple here, where this is where Karumba is pulling all that information. So you can see for each element, each member type, it defines things like the depth and the thickness and eccentricity, all sorts of things that you don't really need to figure out because Karumba's already done that for you. It's just super useful. So you use the read cross-section table, which is down in the cross-section menu of Karumba bar all the way at the bottom. And then you take the cross-section selector and take from cross-sections of the table into the cross-section selector, and then draw from the cross-section over to the cross-section assemble. Now what cross-section selector allows you to do is decide which of the many beams that are listed in the cross-section table you want to use for your members. So if you double-click and put a double slash again to open a panel and draw over here, there's two ways you can call out members. You can straight name them, and so I'm going to put for this one a W8 by 13 by 13. Then right-click to get out of it, and you can see immediately that it's reacted because it's changed those beams into a W8 by 13. You can also, if you see here, every member has an item number. W8 by 13 is number 381. So I can just type in 381, and it does the same thing because I'm calling out the exact same member. So that, in essence, is the easiest way to pull out standardized cross-sections.